Welcome. We are beginning a new topic today, binomial probability distribution. Here are the objectives that we look forward to achieving at the end of the lesson. At the end of the lesson, you should be able to identify a binomial situation, and you should be able to understand and use the binomial probability distribution to solve problems. This lesson on binomial probability distribution is a continuation of the lesson on probability, which is available on this channel. I will leave the link to that lesson in the description of this lesson. In that lesson, I explained the basic concept of probability. I also explained some terms used in probability, and we solved some questions on finding the probability of some events. Since this lesson is a continuation of that lesson, I will assume that you have already studied that lesson and you understand it. So in this lesson, I will be using some terms that I have already explained in the lesson on probability. If you have not studied the lesson on probability, I would advise that you study it before you study this one. Once again, I will leave the link to that lesson in the description of this lesson, so you can check it out if you want to. Now that we have that out of the way, let's continue with our lesson on binomial probability distribution. Binomial probability distribution. Let's consider the following situations. The first one is tossing a coin. The second one is writing an examination. The third one is rolling a die for a specific number. And the fourth one is answering a yes or no question. When you toss a coin, you have only two possible outcomes. In the lesson on probability, we learned that when you toss a coin, it's either you get a head or a tail. These are the only two possible outcomes, and you will get one or the other. So it's either you get a head or a tail. Both of them can't happen at the same time. When you toss a coin, you can't get a head and a tail. You will get a head or a tail. You get one or the other. Let's consider the second situation, when you write an exam. When you write an exam, it is either you pass the exam or you fail the exam. So there are only two possible outcomes. It's either you pass or you fail. You can't pass and fail at the same time. It's either you are passing the exam or you are failing the exam. You have two possible outcomes, and it's either one happens or the other. When you roll a die for a specific number, let's say you are playing a game where you use a die and you want to roll the die for, let's say, the number 3. When you roll the die for a specific number like that, it's either you roll the number or you don't. So like I said, if you are rolling the die for, let's say, the number 3, it's either you roll the number 3 or you don't. There are only two possible outcomes. It's either you are rolling the number or you don't. Those two possible outcomes can't happen at the same time. It's either one happens or the other. When you are asked a yes or no question, you have only two possible outcomes. It's either your answer is a yes or a no. Your answer can't be a yes and no. It's either you answer yes or no. You can see that in all the four situations that you have considered here, in each of them, you have two possible outcomes. So when you toss a coin, it's either you get a head or a tail. When you write an exam, it's either you pass or you fail. When you roll a die for a specific number, it's either you get the number or you don't. When you are asked a yes or no question, it's either yes or no. Each of them have two possible outcomes, and those two possible outcomes cannot happen together. Such a situation is known as a binomial situation. A binomial situation is any situation that have two possible mutually exclusive outcomes. Mutually exclusive outcomes means that the outcomes can't happen together. So for example, when you toss a coin, you can't get a head and a tail together. It's either you get a head or a tail. When you have a situation like that, where you have only two possible outcomes, and those two possible outcomes are mutually exclusive, then the situation is known as a binomial situation. So tossing a coin is a binomial situation. Writing an examination is a binomial situation. Rolling a die for a specific number is a binomial situation. Answering a yes or no question is a binomial situation. I'm sure you can think of other possible binomial situations. Any situation that have only two possible mutually exclusive outcomes is known as a binomial situation. In the lesson on probability, which I've already referred to, we learned how to find the probability of some events in a binomial situation. Let's do a quick recap. We have learned that tossing a coin is a binomial situation. So let's say we have a fair coin and we toss it 3 times. We are going to find the probability of getting exactly 2 heads. We learned how to do this in the lesson on probability, so I'll quickly go through it here. In that lesson, we learned that to get the possible outcomes when you toss a fair coin 3 times, you first have to generate the possible outcomes when you toss the coin 2 times. When you toss a coin once, you either have a head or a tail. So head tail here will be the first coin, and then head tail here will be the second coin. This one will give us the possible outcomes when you toss the coin 2 times. When you cross them, you have head head, that's what you have here, head tail, that is what you have here, tail head, that is what we have here, and tail tail, that's what we have here. So when you toss a coin 2 times, the possible outcomes are head head, head tail, tail head, and tail tail. To get the possible outcomes when you toss the coin 3 times, we will cross the possible outcomes when you toss the coin 2 times, which is head head, head tail, tail head, tail tail, with the possible outcomes when you toss the coin once. So the head head, head tail, tail head, tail tail here gives us the possible outcomes when you toss the coin 2 times, and then the head tail here gives us the possible outcomes when you toss the coin once. When you cross them, you have head head head, head head tail, head tail head, head tail tail, tail head head, tail head tail, tail tail head, and tail tail tail. So this gives us the possible outcomes when you toss the coin 3 times. When you count them, they are 1, 2, 3, 4, 5, 6, 7, 8. 8 in number. So when you toss a fair coin 3 times, the sample space contains 8 members. Now we are looking for the probability of getting exactly 2 heads. So we go through the sample space and we count the members with exactly 2 heads. Remember, we are looking for exactly 2 heads. So that will be head, head, tail, head, tail, head, tail, head, head. The first one, which is head, 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 contains exactly 3 heads. We are looking for exactly 2 heads. That's why we chose head, head, tail, tail, head, and tail, head, head. The number of members with exactly 2 heads are 3, and the sample space is 8. So the probability of getting exactly 2 heads will be the number of members with exactly 2 heads, which is 3, divided by the sample space, which is 8. We learned how to do this in the lesson on probability. I'm sure that by now you are conversant with this. As we have learned, tossing a coin is a binomial situation. In this lesson on binomial probability distribution, we are going to learn how to use the binomial probability distribution to find the probability of events like these when you have a binomial situation. So we are going to solve questions like this, but this time we are going to use the binomial probability distribution. Let's learn more about the binomial probability distribution. As we have learned, in any binomial situation, there are 2 mutually exclusive outcomes. That is, there are 2 outcomes that can't happen together. So it's either you get one or the other. Because there are only two mutually exclusive outcomes, one of the outcomes can be said to be a success and the other a failure. Let's consider tossing a coin. We know that when you toss a coin, it's either you get a head or a tail. So when you toss a coin and you are hoping to get a head, then we can say that the probability of getting a head is success because you are hoping to get a head. If you toss a coin and you are hoping to get a tail, then the probability of getting a tail will be considered as success because that is what you are hoping to get. And if one is success, then the other will be failure. So let's say you toss a coin and you hope to get a head, then the probability of getting a head will be success. And the other one, which is the probability of getting a tail, will be failure because here we have only two outcomes. So if one is success, then the other will be failure. In the same way, when you toss a coin and you hope to get a tail, then the probability of getting a tail will be success and the probability of getting a head will be failure. So in any binomial situation, the probability of one of the outcomes can be described as a success and the other a failure. So let's say that you have a binomial situation and we let P equal to the probability that success will occur. So in this case, let's go back to our example, tossing a coin. When you toss a coin, you either get a head or a tail. Let's say that we hope to get a head, right? We hope to get a head. So if we hope to get a head, then the probability of getting a head in a single trial will be success. So here, the probability of getting a head will be success. And let's denote the probability of getting a success with P. Let's denote the probability of getting a failure in a single trial with Q. So in this case, if getting a head is success, then getting a tail will be failure. Let's denote that with Q. Let's say that the trial was repeated n number of times. So here the coin was tossed, let's say 8 number of times. So the tossing of the coin was repeated 8 number of times. So that would be n, which is the number of trials. If this is the case, then the probability of getting x successes will be given by n combination x times p exponent x times q exponent n minus x. This is the binomial probability distribution. When you have a binomial situation, there are only two mutually exclusive outcomes. One of the outcomes can be described as a success and the other can be described as a failure. If P is the probability of getting success in a single trial, and Q is the probability of getting failure in a single trial, and N is the number of times that the trial was repeated or the number of trials, then the probability of getting X number of successes will be given by N combination X, P exponent X, Q exponent N minus X. Let's apply this to a binomial situation. That will throw more light on this. Let's say that we have a fair coin and the coin is tossed 10 times. So you have a fair coin that is tossed 10 times and we want to find the probability of getting exactly 3 heads. You see, in this example, the fair coin is tossed 10 times and we want to find the probability of getting exactly 3 heads. If we are to go by the normal process which we learned under the lesson on probability, we will have to draw a very big table to find a set of all possible outcomes when you toss a fair coin 10 times, and that will be very tedious. But with the help of the binomial probability distribution, we can easily find the probability of this event. Let's analyze this binomial situation we have here. We have learned that when you have a binomial situation, the probability of getting x successes is given by the formula n combination x, p exponent x, q exponent n minus x. Let's find what p is, q is, n is, and x is in this situation. Let's begin with p. P P is the probability that success will occur in a single trial. Here, what will be success for us? The question wants us to find the probability of getting exactly 3 heads. So it means that here, getting a head is success. We are looking for 3 heads. So getting a head will be success. So P will be the probability of getting a head in a single trial. We know that when you toss a coin, the possible outcomes are head and tail. So the probability of getting a head in a single trial will be the number of heads, which is 1, divided by the number of members in the sample space, which is 2, head and tail. So that will be 2. So the probability of getting a head in a single trial will be 1 divided by 2. So that will be P here. If getting a head is success, then getting a tail will be failure. So K will be the probability of getting a tail in a single trial, which is also 1 divided by 2, because when you toss a coin, the 2 possible outcomes are head and tail. So the probability of getting a tail in a single trial will be the number of tails, which is 1, divided by the number of members in the sample space, which is 2. So we now have the value of P and Q. Let's find N. What is N? N is the number of trials. Here, the coin was tossed 10 times. So the trial of tossing the coin was repeated 10 times. So N will be the number of times the coin was tossed, which is 10. What is X? In this formula, X is the number of successes we want. Now we know that the probability of getting a head will be success. But how many successes do we want? How many heads do we want? The question says that we should find the probability of getting exactly 3 heads. So we want success to occur 3 times. We want 3 heads. So X will be 3. That's the number of heads we want to get. The probability of getting a head is success. But how many times do we want that to occur? We want that to occur 3 times. So X will be the number of heads we want to get, which is 3. So we have the value of N, we have the value of X, we have the value of P, and we have the value of Q. We can substitute them into this formula to get the probability of getting exactly 3 heads. When we do that, you have N is 10, so 10 combination, X is 3, so 3, times P is half, so half exponent, X, which is 3, times Q is half, so half exponent, N, which is 10, minus X, which is 3. 10 minus 3 gives us 7. And this gives us 15 divided by 125. In the lesson on binomial theorem, I explained how to use the calculator to find a combination. Let's say you have 10 combination 3. Let's quickly do that on the calculator. Let's learn how to use it to find a combination. Let's say you want to find 10 combination 3. To get 10 combination 3, you first enter 10, then you press on shift, then you press on the division sign, that gives you combination, and then 3. So that gives us 10 combination 3. When you press equal to, this gives us 120. So let's say if you want to find 5 combination 4, you press on 5, then you press on shift, then the division sign, and then 4. And that gives us 5 combination 4. Then you press equal to, and that gives us 5. So this is how to use the calculator to find a combination. When you find 10 combination 3 times half exponent 3 times half exponent 7 on your calculator, you are going to have 15 divided by 125. So you can see that we have been able to use the binomial probability distribution to find the probability of this event in this binomial situation without drawing the table to find the number of possible outcomes as we used to do in the lesson on probability. We are now going to use what we have learned here to solve some questions. we are going to solve some questions on finding the probability of some events in binomial situations. Let's consider the first question. A fair coin is tossed 6 times. Find the probability of getting I exactly 2 heads, II exactly 3 tails. Tossing a coin is a binomial situation because when you toss a coin, you have 2 mutually exclusive outcomes. Because this is a binomial situation, we can use the binomial probability distribution to find the probabilities of these events. Let's begin with the first one. The probability of getting exactly 2 heads. When you toss a coin, you have 2 mutually exclusive outcomes. It's either you get a head or you get a tail. So when you toss a coin once, you have 2 members in the sample space, a head or a tail. The probability of getting a head will be the number of heads, which is 1, divided by the number of members in the sample space, which is 2. So the probability of getting a head will be 1 divided by 2. In the same way, the probability of getting a tail will be the number of tails, which is 1, divided by the number of members in the sample space, which is 2. So the probability of getting a tail is 1 divided by 2. And so we can say that when a coin is tossed once, the probability of getting a head is 1 divided by 2, and the probability of getting a tail is 1 divided by 2. In this question, we are told that the coin was tossed 6 times, and we want to get exactly 2 heads. This is a binomial situation, and so we can use the binomial probability distribution to find the probability of getting exactly 2 heads. The probability of getting exactly 2 heads will be given by n combination x times p exponent x times q exponent n minus x. Let's find the values of n, x, p, and q so that we can substitute them here. N is the number of times the coin was tossed. Here, we are told that the coin was tossed 6 times, so n will be equal to 6. X is the number of heads we want to get. The question says that we should find the probability of getting exactly 2 heads. So we want to get 2 heads, and so x will be equal to 2. P is the probability of success. Here, we are looking for the probability of getting exactly 2 heads. So getting a head is considered as success. So the probability of getting a head will give us the probability of success. The probability of getting a head is 1 divided by 2. So the probability of success, which is P, will be equal to 1 divided by 2. If the probability of getting a head is success, then the probability of getting a tail is failure, and Q is the probability of failure. So the probability of failure, which is Q, will be equal to the probability of getting a tail, which is 1 divided by 2. We have the values of P, Q, and X, so we can substitute them here to get the probability of getting exactly 2 heads. When we do that, we are going to have 6 combination 2 times half exponent 2 times half exponent n minus x. N is 6 and x is 2, so that will give us 6 minus 2, which is 4. And this gives us 15 divided by 64. So the probability of getting exactly 2 heads is 15 divided by 64. Let's consider the second event, the probability of getting exactly 3 tails. We have learnt that when the coin is tossed once, the probability of getting a head is half. The probability of getting a tail is also half. The coin was tossed 6 times. Here, we are looking for the probability of getting exactly 3 tails. So we want 3 tails. The number of tails we want to get is equal to 3. Since this is a binomial situation, we can use the binomial probability distribution, which is that the probability of getting exactly 3 tails will be n combination x, p exponent x, q exponent n minus x. Let's find the values of n, x, p, and q in this situation. N is the number of times the coin was tossed, so n is equal to 6. X will be the number of tails we want to get. Always remember that X is the number of successes we want to get. Here, we are looking for exactly 3 tails. So getting a tail will be success. So the number of tails we want to get will be X, and X will be 3. P is the probability of success. As I've already explained, we want to get 3 tails. So in this situation, getting a tail is considered success. So P, which is the probability of success, will be the probability of getting a tail. And the probability of getting a tail is half. So P is equal to half. If the probability of getting a tail is success, then the probability of getting a head will be failure. And Q is the probability of failure. The probability of getting a head is half. So the probability of failure, which is Q, will be equal to half. We have the values of P, Q, and an X, so we will substitute them here. When we do that, we have 6 combination 3 times half exponent 3 times half exponent n minus x. N is 6 and x is 3, so we have 6 minus 3, which is 3. And this gives us 5 divided by 16. So the probability of getting exactly 3 tails is 5 divided by 16. Let's consider the next question. In an examination, 90% of the candidates passed. If 8 of the candidates are selected at random, calculate the probability that I, exactly 5 passed, II, at most 3 failed. This is a binomial situation because in an examination, you are going to have 2 mutually exclusive outcomes. If you select a candidate, it's either the candidate passed or the candidate failed. Because this is a binomial situation, we can use the binomial probability distribution to find the probability of these 2 events. Let's consider the first one. Exactly 5 passed. From the question, we are told that 90% of the candidates passed. This means that if you select 100 candidates, 90 of them passed. So the probability of passing will be equal to the number of candidates that passed, which is 90, divided by the number of selected candidates, which is 100. And that gives us 0.9. So the probability of passing is 0.9. In the lesson on probability, we learned that the probability that an event will happen plus the probability of the opposite of that event is equal to 1. So for example, when you toss a coin, the probability of getting a head plus the probability of getting a tail is equal to 1. The probability that Amma will go to school plus the probability that Amma will not go to school is equal to 1. The probability that an event will happen plus the probability of the opposite of that event is equal to 1. We learned this in the lesson on probability. Here, we know that passing and failing are opposites of each other. So it means that the probability that a candidate will pass plus the probability that the candidate will fail is equal to 1. And so if we have the probability that a candidate will pass, then we can say that the probability that the candidate will fail will be equal to 1 minus the probability that the candidate will pass. So the probability of failing will be 1 minus the probability of passing, which is 0.9. And this gives us 0.1. The question tells us that the number of candidates that were selected is equal to 8. Here, we are looking for the probability that exactly 5 candidates will pass. So the number of candidates who passed is equal to 5. From the binomial probability distribution, we know that the probability that exactly 5 candidates pass will be given by n combination x times p exponent x times q exponent n minus x. So let's find the values of n, x, p, and q so that we can substitute it here. N is the number of candidates that were selected, so n is equal to 8. X is the number of candidates that passed, so x will be equal to 5. P is the probability of success. Now here, we are looking for the probability that 5 candidates passed. the probability that 5 candidates passed. So passing will be considered as success. So the probability of passing will be the probability of success. And P is the probability of success. The probability of passing is 0.9. So P will be equal to 0.9. If passing is success, then failing will be failure. K is the probability of failure. The probability of failing is 0.1. So K will be equal to 0.1. We have the values of P, K, N, and X. So we substitute them here for the probability. When we do that, you have 8 combination 5, 0.9 exponent 5, 0.1 exponent 3. And this gives us 0.0331. So the probability that exactly 5 candidates passed is 0.0331. Let's consider the second event. The second event is at most 3 failed. We are going to find the probability that at most 3 failed. Now remember that the question said 8 candidates were selected. We are looking for the probability that at most 3 of them failed. If 8 candidates were selected and at most 3 of them failed, then it means that it's either no candidate failed, that's 0 candidates failed, or 1 candidate failed, or 2 candidates failed, or 3 candidates failed. These 4 conditions will satisfy this situation. At most 3 failed. If at most 3 failed, that is not more than 3 failed, then it means that it's either no one failed, which is the first one, 0 candidates failed, or 1 candidate failed, or 2 candidates failed, or 3 candidates failed. So if we want the probability that at most 3 candidates failed, then we will have to find the probability that no one failed, that is 0 failed, the probability that 1 candidate failed, the probability that 2 candidates failed, the probability that 3 candidates failed, then we add them. This will give us the probability that at most 3 candidates failed. It's either 0 candidates failed, or 1 candidate failed, or 2 candidates failed, or 3 candidates failed. In the lesson on probability, we learned that in probability, when you hear or, it means you are going to add. That is why here you have to add these 4 probabilities. So we will find these 4 probabilities and then we will add the results. Let's begin with the first one, 0 failed. We are going to find the probability that 0 failed. We know that the probability of passing is 0.9. The probability of failing is 0.1. 8 candidates were selected. Here, we are looking for the probability that 0 failed. So the number of candidates who failed will be 0. We know that the probability that 0 candidates failed will be given by n combination x, p exponent x, q exponent n minus x. So we are going to find the values of n, x, p, and q so that we can substitute them here. N is the number of candidates that were selected, so n will be 8. X is the number of candidates who failed. Here, the number of candidates who failed is 0, so x will be 0. P is the probability of success. Now, let's look at this. This is very interesting. You see here, we are looking for the probability that 0 candidates failed. So we are looking for failure. Because we are looking for failure, failing will now be considered as success, because that is what we are looking for. We are looking for the probability that 0 candidates failed, so we are looking for failure. And because we are looking for failure, failing will be considered as success. So here, P, which is the probability of success, will be the probability of failing. The probability of failing is 0.1. So P, which is our probability of success, will be 0.1. If failing is success, then passing will be failure. So here, Q, which is the probability of failure, will be the same as the probability of passing, which is 0.9. So Q will be 0.9. We now have the values of P, Q, N, and X, so we substitute them here. When we do that, you have 8 combination 0, 0.1 exponent 0, 0.9 exponent 8, and this gives us 0.4305. So the probability that no candidate field or 0 candidates field is 0.4305. This is the first case. Let's consider that for the second case, which is one candidate failed. If one candidate failed, then the number of candidates who failed will be 1. So our x is 1. Failing is our success, so p is equal to 0.1. Passing is failure, so k is equal to 0.9. And the number of candidates that were selected is 8, so n is equal to 8. We will substitute that information here. You have 8 combination 1, 0.1 exponent 1, 0.9 exponent 7, and this gives us 0.3826. So the probability that one candidate failed is 0.3826. Let's consider the third situation, that is 2 candidates failed. If 2 candidates failed, then the number of candidates who failed is equal to 2, so x is 2. Failing is success, so p is equal to 0.1. Passing is failure, so k is equal to 0.9. The number of candidates that were selected is n, so n is equal to 8. When you substitute that here, you have 8 combination 2, 0.1 exponent 2, 0.9 exponent 6, and this gives us 0.1488. Let's consider the fourth situation, that is 3 candidates failed. If 3 candidates failed, then the number of candidates who failed is 3, so x is equal to 3. Passing is failure, so k is equal to 0.9. Failing is success, so p is equal to 0.1. 8 candidates were selected, so n is equal to 8. When you substitute that here, you have 8 combination 3, 0.1 exponent 3, 0.9 exponent 5, and this gives us 0.0331. So the probability that 3 candidates failed is 0.0331. So we now have the probabilities of these 4 events. The first one, 0 candidates failed, we have 0.4305. The second one, 1 candidate failed, we have 0.3826. The third one, 2 candidates failed, we have 0.1488. The fourth one, 3 candidates failed, we have 0.0331. The probability that at most 3 candidates failed will be the summation of these 4 probabilities. So we add them. 0.4305 plus 0.3826 plus 0.1488 plus 0.0331. And this gives us 0.995. So the probability that at most 3 candidates failed is 0.995. Let's consider the next question. A survey carried out among a group of secondary school students showed that 2 out of every 10 students buy textbooks. If 5 students are randomly selected from the group, find, correct with 3 decimal places, the probability that A. Exactly 3 students buy textbooks, B. Less than 4 students buy textbooks, and C. At least 2 students buy textbooks. This is a binomial situation because here you are going to have 2 mutually exclusive outcomes. When you select a student, it's either the student buy textbooks or the student does not buy textbooks. Because this is a binomial situation, we can use the binomial probability distribution to find the probability of these events. Let's begin with the first one. Exactly 3 students buy textbooks. We are going to find the probability that exactly 3 students buy textbooks. From the question, we are told that 2 out of every 10 students buy textbooks. This means that if you select 10 students, 2 of them buy textbooks. So the probability that a student buy textbooks will be equal to the number of students who buy textbooks, which is 2, divided by the number of students selected, which is 10, and this gives us 0.2. The probability that a student buy textbooks is 0.2. The probability that a student buy textbooks and the probability that a student does not buy textbooks are opposite to each other. And so if we have the probability that a student buy textbooks, we can find the probability that a student does not buy textbooks, because we know that the probability that an event will happen plus the probability that the opposite of that event will happen will be equal to 1. So here, the probability that a student does not buy textbooks will be equal to 1 minus the probability that a student buy textbooks, which will be 1 minus 0.2, and that gives us 0.8. So the probability that a student selected from the class buy textbooks is 0.2, and the probability that a student selected from the class does not buy textbooks is 0.8. From the question, we are told that 5 students are selected. Here, we want to find the probability that exactly 3 of the students buy textbooks. So the number of students who buy textbooks is equal to 3. We have learned from the binomial probability distribution that the probability that exactly 3 students buy textbooks will be given by n combination x, p exponent x, q exponent n minus x. Let's find n, x, p, and q. N is the number of students selected, which is 5. X is the number of students who buy textbooks, which is 3. P is the probability of success. Here, we want to find the probability that exactly 3 students buy textbooks. So buying textbooks is considered success. So the probability of success will be the probability that a student buy textbooks. The probability that a student buy textbooks is 0.2. So P, which is the probability of success, will be equal to 0.2. Q will be the probability of failure. The probability of failure will be the probability that a student does not buy textbooks. So Q will be 0.8. We have the values of P, Q, N, and X. So we substitute them here. When we do that, we have 5 combination 3, 0.2 exponent 3, 0.8 exponent 2. And this gives us 0.051. Remember, the question said we should correct our answer to 3 decimal places. So the probability that exactly 3 students buy textbooks is 0.051. Let's consider the second part of the question. We are going to find the probability that less than 4 students buy textbooks. If less than 4 students buy textbooks, then it means that it's either 0 students buy textbooks, 1 student buy textbooks, 2 students buy textbooks, or 3 students buy textbooks. This will give us less than 4 students. It's either you have 0, 1, 2, or 3. So to get the probability that less than 4 students buy textbooks, we are going to find the probability of these 4 events, then we will add them. Let's begin with the first one, the probability that no student buy textbooks or 0 student buy textbooks. We have learned that the probability that a student buy textbooks is 0.2. The probability that a student does not buy textbooks is 0.8. 5 students are selected. Here, we want to find the probability that 0 students buy textbooks. So the number of students who buy textbooks is 0. From the binomial probability distribution, the probability will be given by n combination x, p exponent x, q exponent n minus x. So we are going to find the values of n, x, p, and q, then we substitute it here for the probability. N is the number of students selected, which is 5. X is the number of students who buy textbooks, which is 0. P is the probability of success. Here we want students who buy textbooks. So buying textbook will be considered success. And so here P will be 0.2, which is the probability that a student buy textbooks. And Q will be the probability of failure, which is the probability that a student does not buy textbooks, and that is 0.8. So we have the values of P, Q, N, and X. We substitute it here for the probability. When we do that, we have 5 combination 0, 0.2 exponent 0, 0.8 exponent 5. And this gives us 0.32768. Let's consider the next condition. 1 student buy textbooks. If 1 student buy textbooks, then the number of students who buy textbooks is 1. So X is equal to 1. We have the value of P, Q, and N here. So we substitute it here. When we do that, we have 5 combination 1, 0.2 exponent 1, 0.8 exponent 4. And this gives us 0.4096. Let's consider the next condition. 2 students buy textbooks. If 2 students buy textbooks, then the number of students who buy textbooks is equal to 2. So X is equal to 2. We have the values of P, Q, and N here. You substitute them into the formula. When you do that, you have 5 combination 2, 0.2 exponent 2, 0.8 exponent 3. And this gives us 0.2048. Let's consider the next condition. 3 students buy textbooks. If 3 students buy textbooks, then the number of students who buy textbooks is equal to 3, so X is equal to 3. We have the value of P here, Q here, and N here. You substitute them into the formula, and you have 5 combination 3, 0.2 exponent 3, 0.8 exponent 2. And this gives us 0.0512. So now we have the probability that 0 students buy textbooks, that is 0.32768. We have the probability that 1 student buy textbooks, which is 0.4096. We have the probability that 2 students buy textbooks, which is 0.2048. And we also have the probability that 3 students buy textbooks, which is 0.0512. To get the probability that less than 4 students buy textbooks, we will add these 4 probabilities. When we do that, we are going to have 0.32768 plus 0.4096 plus 0.2048 plus 0.0512. When you add them, you have 0.993. So the probability that less than 4 students buy textbooks is 0.993. Let's consider the third part of the question. The third part of the question says that at least 2 students buy textbooks. Now remember that 5 students were selected. So if at least 2 students buy textbooks, then it means that it is either 2 students buy textbooks, 3 students buy textbooks, 4 students buy textbooks, or 5 students buy textbooks. If at least 2 students buy textbooks, then it is either 2 students buy textbooks, 3 students buy textbooks, 4 students buy textbooks, or 5 students buy textbooks. This will give us at least 2 students. So to get the probability that at least 2 students buy textbooks, we will find the probability of these 4 events, then we will add them. Let's begin with the first one, the probability that 2 students buy textbooks. We know that the probability that a student buy textbooks is 0.2. The probability that a student does not buy textbooks is 0.8. The number of students that were selected is 5. Here, we want the probability that 2 students buy textbooks. So the number of students who buy textbooks will be 2. The probability will be given by n combination x, p exponent x, q exponent n minus x. N is the number of students selected. X is the number of students who buy textbooks. P is the probability of success. Here, buying textbooks is success. So P will be the probability that a student buy textbooks, which is 0.2. And Q will be the probability of failure, which is the probability that a student does not buy textbooks, which is 0.8. When you substitute the value of N, X, P, and Q here, you have 5 combination 2, 0.2 exponent 2, 0.8 exponent 3. And this gives us 0.2048. The next one will be the probability that 3 students buy textbooks. So the number of students who buy textbooks is equal to 3. X is equal to 3 here. You substitute this information into the formula and you have 5 combination 3, 0.2 exponent 3, then 0.8 exponent 2. And this gives us 0.0512. The next one will be the probability that 4 students buy textbooks. If 4 students buy textbooks, then the number of students who buy textbooks is equal to 4. So X is equal to 4. We have the values of P, Q, and N here. So you substitute them in here. When you do that, you have 5 combination 4, 0.2 exponent 4, 0.8 exponent 1. And this gives us 0.0064. Then the last one will be the probability that 5 students buy textbooks. If 5 students buy textbooks, then the number of students who buy textbooks is equal to 5. So x is equal to 5. We have the values of P, Q, and N here. You substitute them into the formula. You have 5 combination 5, 0.2 exponent 5, 0.8 exponent 0. And this gives us 0.00032. So now we have the probability that 2 students buy textbooks, the probability that 3 students buy textbooks, the probability that 4 students buy textbooks, and the probability that 5 students buy textbooks. To get the probability that at least 2 students buy textbooks, we will add these 4 probabilities. When we add them, we are going to have 0.263. So the probability that at least 2 students buy textbooks is 0.263. Let's consider the next question. In a community, 10% of the people tested positive to the HIV virus. If 6 persons from the community are selected at random, calculate, correct to 4 decimal places, the probability that A. Exactly 5 tested positive to the virus, B. None tested positive to the virus, and C. At most 2 tested positive to the virus. This is a binomial situation because you are going to have 2 mutually exclusive outcomes. That is, if you select someone from the community, it is either the person is HIV positive or HIV negative. Because this is a binomial situation, we can use the binomial probability distribution to find the probability of these events. Let's begin with the first one. Exactly 5 tested positive to the virus. From the question, we are told that 10% of the people tested positive to the virus. This means that if you select 100 people from the community, 10 of them are HIV positive. So the probability that someone is HIV positive will be equal to the number of people who are HIV positive, which is 10, divided by the total number of people selected, which is 100. 10 divided by 100 gives us 0.1. So the probability that a person from the community is HIV positive is 0.1. The probability that a person is HIV positive plus the probability that a person is HIV negative will be equal to 1 because they are opposite to each other. And so if the probability that a person is HIV positive is 0.1, then the probability that a person is HIV negative will be equal to 1 minus 0.1, which gives us 0.9. So now we have the probability that a person is HIV positive to be 0.1 and the probability that a person is HIV negative to be 0.9. The question says that 6 people are selected from the community. So the number of people selected is equal to 6. Here, we want to find the probability that exactly 5 of them tested positive to the virus. That is, exactly 5 of them are HIV positive. So the number of people who tested positive is equal to 5. The probability will be given by n combination x, p exponent x, q exponent n minus x. N will be the number of people selected, which is 6. X will be the number of people who tested positive, which is 5. P is the probability of success. Here, we are looking for the probability that exactly 5 tested positive to the virus. So testing positive will be success here. And so the probability of success will be the probability of the person testing positive, which is 0.1. So P will be equal to 0.1. And then obviously the probability of failure will be the probability that the person tested negative, which is 0.9. So Q, which is the probability of failure, will be 0.9. We have the values of P, Q, N, and X. We substitute it here for the probability. When we do that, you have 6 combination 5, 0.1 exponent 5, 0.9 exponent 1. And this gives us 0.0001. Remember, the question said we should correct our answer to 4 decimal places. Let's consider the B part of the question. It says that we should find the probability that none tested positive to the virus. Remember, 6 people were selected, and we want to find the probability that none of them tested positive to the virus. If none tested positive to the virus, then it means that the number of people who tested positive to the virus is 0. Okay. We know that the probability that a person tested positive is 0.1. The probability that a person tested negative is 0.9. 6 people were selected, so the number of people selected is equal to 6. We are looking for the probability that none tested positive to the virus. So here, the number of people who tested positive will be 0. The probability will be given by n combination x, p exponent x, q exponent n minus x. N will be the number of people selected, which is 6. X will be the number of people who tested positive, which is 0 in this case. P will be the probability of success. Here we are looking for the probability that none tested positive. So testing positive will still be considered as success. So here the probability that someone tested positive, which is 0.1, will be the probability of success. So P will be equal to 0.1. And Q will be the probability of failure, which is 0.9. When we substitute the values of P, Q, N, and X here, we are going to have 6 combination 0, 0.1 exponent 0, 0.9 exponent 6. And this gives us 0.5314. So the probability that none of them tested positive is 0.5314. Let's consider the third part of the question. It says that we should find the probability that at most 2 tested positive to the virus. Remember that 6 people were selected, and we want to find the probability that at most 2 of them tested positive to the virus, which means that we want to find the probability that not more than 2 people tested positive to the virus. If not more than 2 people tested positive to the virus, then it means that it's either no one tested positive, that is 0 people tested positive, 1 person tested positive, or 2 people tested positive. These 3 will give us the probability that at most 2 tested positive to the virus. So to get the probability that at most 2 tested positive to the virus, we are going to find the probability of these 3 events, then we will add them. Let's begin with the first one, the probability that 0 tested positive. We have the probability that a person tested positive to be 0.1. We have the probability that a person tested negative to be 0.9. 6 people were selected. Here we want to find the probability that 0 tested positive. So the probability that the number of people who tested positive is 0. And this probability will be given by n combination x, p exponent x, q exponent n minus x. N is the number of people who were selected, so n is equal to 6. X is the number of people who tested positive, so that is 0. P is the probability of success. Here, testing positive is considered success, so P will be equal to 0.1. And Q is the probability of failure, so Q will be equal to 0.9. When we substitute that here, you have 6 combination 0, 0.1 exponent 0, 0.9 exponent 6. And this gives us 0.531441. Let's move on to the second condition. 1 tested positive. If 1 tested positive, then the number of people who tested positive is equal to 1, so x is equal to 1. We have the values of P, Q, and N here. You substitute them in here. You have 6 combination 1, 0.1 exponent 1, 0.9 exponent 5. And this gives us 0.354296. Let's move on to the third condition, which is the probability that 2 tested positive. If 2 tested positive, then the number of people who tested positive is equal to 2, and so x is equal to 2. We have the values of P, Q, and x. You substitute them in here. You have 6 combination 2, 0.1 exponent 2, 0.9 exponent 4. And this gives us 0.098415. So now we have the probability that 0 people tested positive, the probability that 1 person tested positive, and the probability that 2 people tested positive. To get the probability that at most 2 tested positive, we will add these 3 probabilities. When you add them, you have 0.9842. So the probability that at most 2 people tested positive is 0.9842. Let's consider the next question. At the end of a full time, a football match between teams A and B was goalless. The winning team had to be decided through penalty kicks. Each team had to take 5 kicks. The probability that a kick by team A will result in a goal was 0.8, and for team B, the probability was 0.3. Find, correct with 3 decimal places, the probability that the final scores would be I, 4-2 in favor of team B, II, 5-0 in favor of team A. This is a binomial situation because there are 2 mutually exclusive outcomes. In a penalty shootout, it's either the player kicking the ball scores or he misses. That makes this a binomial situation. Because this is a binomial situation, we can use the binomial probability distribution to find the probability of these events. Let's consider the first one. The probability that the final scores will be 4-2 in favor of team B. If the final score is 4-2 in favor of team B, then it means that team B scores 4 and team A scores 2. If the penalty shootout finishes 4-2 in favor of team B, then it means that team B scores 4 and team A scores 2. So the probability that the final score will be 4-2 in favor of team B will be the probability that team B scores 4 and team A scores 2. In the lesson on probability, we learned that when we see the word "and," we will replace it with multiplication. So here, the probability that the shootout ends 4-2 in favor of team B will be equal to the probability that team B scores 4 times the probability that team A scores 2. So we are going to find the probability that team B scores 4. Then we will find the probability that team A scores 2. And then after that, we will multiply them to get the probability that the penalty shootout will end 4-2 in favor of team B. Let's begin with the first one, the probability that team B scores 4. From the question, we are told that the probability that a kick by team B will result in a goal was 0.3. So it means that the probability that team B scores is 0.3. The probability that team B scores and the probability that team B misses are opposite to each other. So it means that when you add those 2 probabilities, you should get 1. So if we have the probability that team B scores to be 0.3, then we can say that the probability that team B misses will be equal to 1 minus the probability that team B scores, which is 0.3. 1 minus 0.3 will give us 0.7. So the probability that team B scores is 0.3 and the probability that team B misses is 0.7. From the question, we are told that each team kicks 5 times. So each team will take 5 penalty kicks. Here, we are looking for the probability that team B scores 4. So the number of goals scored by team B is 4. We know that the probability will be given by n combination x, p exponent x, q exponent n minus x. N is the number of kicks taken, and that is 5. X will be the number of goals scored, that is 4. P is the probability of success. We are looking for the probability that team B scores. So scoring is considered success here. The probability that team B scores is 0.3. So P, which is the probability of success, will be equal to 0.3. Team B missing will be failure. So kill, which is the probability of failure, will be the probability that team B miss, which is 0.7. We have the values of P, Q, N, and X. We will substitute them here for the probability. When we do that, we have 5 combination 4, 0.3 exponent 4, 0.7 exponent 1. And this gives us 0.02835. So the probability that team B scores 4 is 0.02835. Let's find the probability that team A scores 2. From the question, we are told that the probability that a kick by team A will result in a goal was 0.8. So it means that the probability that team A scores is 0.8. If the probability that team A scores is 0.8, then the probability that team A miss will be equal to 1 minus the probability that team A scores, which should be 1 minus 0.8, and that gives us 0.2. So the probability that team A scores is 0.8, the probability that team A miss is 0.2. Each team takes 5 penalties, so the number of penalties taken by team A is 5. We want the probability that team A scores 2. So the number of goals scored by team A will be 2. The probability is given by n combination x, p exponent x, q exponent n minus x. N is the number of penalty kicks taken, which is 5. X is the number of goals scored, which is 2. P is the probability of success. We are looking for the probability that team A scores 2. So here, scoring is considered success. The probability that team A scores is 0.8. So the probability of success will be 0.8. K is the probability of failure. That will be the probability that team A miss, and that's 0.2. We have the values of P, Q, N, and X here. You substitute it into the formula, and you have 5 combination 2, 0.8 exponent 2, 0.2 exponent 3. And this gives us 0.0512. We now have the probability that team B scores 4 and the probability that team A scores 2. We have learned that the probability that the penalty shootout will end 4-2 in favor of team B is equal to the probability that team B scores 4 times the probability that team A scores 2. This will be equal to 0.02835 times 0.0512. And this gives us 0.001. So it means that the probability that the final score will be 4-2 in favor of team B is 0.001. Remember, the question said we should correct our answer to 3 decimal places. Let's consider the second part of the question. We are going to find the probability that the final score will be 5-0 in favor of team A. If the final score is 5-0 in favor of team A, it means that team A scores 5 and team B scores 0. If the final score is 5-0 in favor of team A, then it means that team A scores 5 and team B scores 0. So the probability that the final score will be 5-0 in favor of team A will be the probability that team A scores 5 and the probability that team B scores 0. We have and here, so we replace it with multiplication. So that will be the probability that team A scores 5 times the probability that team B scores 0. So to get the probability that the final score is 5-0 in favor of team A, we will find the probability that team A scores 5, and then we will find the probability that team B scores 0. Then we will multiply them. Let's begin with the first one, the probability that team A scores 5. We are going to find the probability that team A scores 5. We know that the probability that team A scores a kick is 0.8. The probability that team A miss is 0.2. In total, each team takes 5 kicks. Here, we are looking for the probability that team A scores 5. So the number of goals scored by team A will be 5. So the team takes 5 kicks and they scored all 5 of them. The probability will be given by n combination x, P exponent x, Q exponent n minus x. N will be the number of kicks, which is 5. X will be the number of goals scored, that is the number of times the success will happen, that is the scoring will happen, which is 5 times. P is the probability of success. We are looking for the probability that team A scores. So scoring is considered success. So P will be equal to 0.8, which is the probability that team A scores. The probability that team A miss will be 0.2. And that gives us the probability of failure. So Q is equal to 0.2. When you substitute it in here, you have 5 combination 5, 0.8 exponent 5, 0.2 exponent 0. And this gives us 0.32768. Now let's find the probability that team B scores 0. The probability that team B scores 0. We know that the probability that team B scores a penalty kick is 0.3. The probability that team B miss is 0.7. The team takes 5 kicks and they score 0. We are looking for the probability that team B scores 0. So the number of goals scored will be 0. The probability will be given by n combination x, P exponent x, Q exponent n minus x. N is the number of kicks taken, which is 5. X is the number of goals scored, which is 0. P is the probability of success. Here we are looking for the probability that team B scores 0. So scoring is considered success, and the probability that team B scores is 0.3. So P will be equal to 0.3. The probability that team B miss will be failure, and the probability that team B miss is 0.7. So the probability of failure will be 0.7. So Q is equal to 0.7. We have the values of P, Q, N, and X. You substitute them in here. You have 5 combination 0, 0.3 exponent 0, 0.7 exponent 5. This gives us 0.16807. So now we have the probability that team A scores 5 and the probability that team B scores 0. We have learned that the probability that the final score is 5-0 in favor of team A is equal to the probability that team A scores 5 times the probability that team B scores 0. And this will be equal to 0.32768 times 0.16807. And this gives us 0.055. So the probability that the final score will be 5-0 in favor of team A is 0.055. Remember, the question said we should correct our answer to 3 decimal places. This is the end of the lesson on binomial probability distribution. Thank you for watching this video. Subscribe to this channel for more videos. See you in the next lesson. Bye-bye.